today we are going to enter into the day 4 session of lab class. So as usual, before entering into the regular class, we will recollect what are the things we have seen in the last class. Then immediately we will enter into the today's class session. Okay. So I hope everyone aware of these things. In day 3 class, we have interfaced switch and buzzer, and we did 2 experiments. One is by reading the switch, we will make the buzzer to on and off control. The second one we created, once I pressed the switch, we will create the required tone. So these are all the 2 exercises what we have did with the help of buzzer and switch. So this is simple on off control. The second one is creating the multiple tones. Okay. Then after this, we have seen the new thing called serial monitor. So serial monitor, simply we displayed some text over in the serial monitor. Then we read some analog value. Then after reading the value, we made those value to appear in the serial monitor. So these are all experiments related to serial monitor. Here we simply type the text. The second one, we read some analog value from the external environment. We made it to type in the serial monitor. Okay, I hope it is clear for everyone. Buzzer and serial monitor is in the last class. So in today's class, as I told already, today we are going to see PWM technique. So pulse width modulation. So it is a very useful technique wherever you think about the controls, not only the on-off control, varying the quantity. Light means intensity, motor means speed, buzzer means volume. Likewise, we have n number of applications for this PWM technique. In today's class, we are going to do 2 things. One is vary the brightness of an LED based on my analog input value. So already you have seen the construction, how to make the circuit diagram, what are the things we have typed in the programming part. Everyone you may aware of the as per this circuit experiment. Okay. Then the next one, RGB, that we will come to later. First we will enter into the today's first exercise. Vary the brightness of an LED based on analog input. Please observe the video over here. Here we have potentiometer. I am changing the duty cycle of the output waveform by changing my analog input value. See, now it is 50%. Again, I am increasing into 75%. Then at last, I brings to 100%. First, you observe the oscilloscope waveform, then come down to the LED brightness. Okay, now I am bring it back 100 to 75, then 50%, then 25%, at last 0. So if you observe the LED brightness also, correspondingly it will get vary. So in today's class, what we are going to do, the same circuit diagram we are going to construct, and we are going to visualize this particular effect. Okay. Then, so pin numbers, I made little modification. See, here I am using A5 because source on A0. Many of them having the doubt only, is it only A0 is we have to use? Not like that. Out of all the pins A0 to A5, I can use any one of the pins. So I made a little modification here. PWM pin, you know, 3, 5, 6, 9, 10, and 11 we can use. So quick recollect of the algorithm, declaration part, then setup, configure the A5 as the input, then digital pin number 3 as output, then make the digital pin to logic low. So here we are using data type as a byte. Then in that byte, I am going to store the A5 value and 3 pin numbers. So I'm going to assign the pin numbers over here. Then in void setup, pin mode, input and output. Okay. Then digital write off. Sorry. Hello. Hello,
yes, sir. It's hearable.
Yes, okay. See, so in declaration part, we declare the pin numbers. See, byte is the new data type. I will show you how to study these things and all. Okay. Then void setup. In void setup, we have configured the pin numbers, input and output. as usual, we made the output pin as a logic low. Okay. In loop function, it is very simple. Read the pot value, map the value, then generate the PWM pulse. Okay. See, read the the analog input pin. So that is A5 we are going to read. Then we are going to map with this. Then we are going to generate the PWM output. Now we will get into the lab portion. Come to Tinkercad. Create new circuit. Create new circuit. I hope it is visible for everyone. PWM, pulse width modulation technique. What are the components I need to fetch? Fetch Arduino board. Then what else I need to take? Breadboard. Breadboard. Then what else we need? We need one resistor, one LED, and then we need potentiometer. Is it okay? Here we will set the potentiometer value as 10 kilo ohm, resistor value as 220 ohm. That's all. Now we will place the component. I kept my resistor, it's a LED. Then I'm going to rotate my resistor. Keep it over here. Then my potentiometer. Is it clear? Now, as usual, we need to power our breadboard first. So take 5 volt. Take 5 volt. Then ground. Ground. That's all. Now we power the breadboard. What else we need to do? Then we need to connect our resistor and potentiometer. So potentiometer first I'm going to connect. So I'm going to connect in the ground. So N terminals we need to connect with the VCC and ground. Then wiper arm. The wiper terminal we need to connect it across the analog input terminal. Okay, A5 here we are going to use. Now today's task we are going to use A5. So this is my analog input. Okay, so what are the things we made? We power the breadboard and also we made the potentiometer to work. So the ground terminal is connected over here. VCC is connected over one end. Then middle terminal wiper arm. From the wiper arm we have connected to A5. Then LED has to be connected in any one of the PWM output pin. So PWM pin number 3 I am going to choose. So even though we have a number of pins, in this task we are going to use pin number 3. 3, 5, 6, 9, 10, 11 are the PWM pins. Okay. So from pin number 3, we power the anode pin. So cathode terminal as usual connected into ground. That's all. Now what we have to do? We have to start type the code. Come to the code part. So as for our program, first we need to declare the pin numbers. So data type I am going to use byte. In the analog input pin. So analog input we are using A5. Then again I am going to use the same data type byte pin PWM pin number 3. Is it visible? Visible for everyone?
Yes, sir, it is visible.
Yes, I can continue. Okay. So initially we declared the pin numbers. In void setup, we are going to configure the particular pin numbers for our current exercise. So pin mode. Hereafter, I am not going to type the pin number. I am going to use only this variable name. Okay. So a input, comma, say this one I am going to use it as an input pin, isn't it? So input, then PWM pin. See, listen, even though we are using the PWM configuration, initially you need to make the pin as an output pin. Don't forget, as like a digital output pin, if you are using PWM mode also, in configuration mode, you need to declare it as a output pin. Then immediately I am going to make digital write off pin number. What is PWM pin, comma, low. This is to, by default, to make the particular pin as a logical low. In loop session, what I have to type? Can anyone tell? Can anyone tell what we have to do? We have to read the status of the analog value, that is from the potentiometer. So integer. So here I am going to use another variable called pot value is equal to analog read. So analog read. Why it is analog read? Since we are going to read the analog quantity, we are going to type the syntax as analog read. Here I am going to simply use analog input. Once I read the value, that corresponding analog value will get stored into the pot value. So pot value we will get from count value from 0 to 1023. But whatever the value we are reading from the analog input pin, we have to write it into the PWM pin. So PWM range is only from 0 to 255. Therefore, I need to map this value. So I'm going to use another variable name called map value, that is equal to, now I am going to introduce a new function map. Within the argument, I am going to type the first one, what variable I need to scale. So pot value is the variable we are going to scale. What is the from value? What is the from value we are reading from the sensor? The from value is 0 to 1023 is the to value. So this is the value we are reading from the analog input. What is the output range we need to set? Output range as per our application 0 to 255. Okay. So this is not a fixed one. If you want to change as per your application, you can modify this. We will show you that one later. Okay. Now what we have did, we read the analog input value and also we made the mapping. Now we need, this is nothing but your duty cycle. This map value is nothing but your duty cycle. Now I need to pass this duty cycle value into analog write function. Thereby we can create the PWM pulse. So analog write off, in which pin we need to create? We need to create the PWM output in pin number 3. So pin number 3 is nothing but pin PWM, comma, what is the value? If you put pot value, it won't work because after 255 it will be not effective. So the map value after the map function, the processed value is map value. That value now I need to pass. It is very simple. As for syntax, analog write, pin number, comma, duty cycle. How we have calculated the duty cycle? Read the analog input value, map it and pass it into the particular pin number. Now we will, what do we have to do? We have to start simulate. See here, now my LED is in off condition because my potentiometer is in minimum position. Now gradually I'm increasing the potentiometer value. See whether brightness gets varied. Now it is maximum. That means 100% duty cycle. Now I am bringing to 50%. See the brightness. See the brightness of your LED. 50% reduced. Again I brings back to 0. Yes. So we achieved. So based on the analog input value, we are going to change the brightness of your LED. So to get more visual effect, what is the output from the particular PWM pin? If you want to check means, please stop the simulation. Please stop the simulation. Here you click all. Here you have one measurement instrument. You have like a multimeter. You have a oscilloscope. So you see in this portion, instruments portion, you have multimeter, power supply, function generator, and oscilloscope. Simply take your oscilloscope. Take your oscilloscope. Set the time into 1 millisecond. Okay, 0.5 millisecond we will keep. Only x-axis you can change it with in this oscilloscope. Y-axis is a fixed one. So what I'm going to do? I'm going to take the negative terminal. Simply I connect it into the negative. Then across the pin number 3 and ground, I'm going to measure the output. So take the wire. Pin number 3 is our PWM output. Simply keep it here. So from we are going to measure the output from pin number 3 with respect to ground. We are going to measure. So if you see, you can view the PWM output based on your analog input value. Now you tell me why it is in 0 value. Since my potentiometer is in minimum position, it shows 0. Now I am varying my potentiometer position. See, what is the percentage of duty cycle? Can you type it in chat box? What is the percentage of duty cycle it is? See, it is 0. Now I am varying to little. Correct. It is 25%. Now you see I am moving to 50%. Yes, it is 50%. Now again I am increasing into 75%. Then 100. 100 is nothing but you are making the pin to logic high. See, it remains in logic high value. If it brings to low, it is logic low. 0 means 0 voltage. 100% means 5 volt. In between, if you keep anywhere, the corresponding percentage duty cycle you can visualize. Is it okay for everyone?
5 volt is again 100% duty cycle.
100%.
0 volt is 0% duty cycle.
0% duty cycle. Is it clear? Now we will see the count value. What are the count we are receiving from the analog, and after mapping, what is the value we are getting? So for that, what we are going to do, here I am going to introduce the command serial dot begin. Serial dot begin. The baud rate I am going to use 9600. So here I need to view these two values. First one is the pot value. We'll do one thing. We'll check the pot value. So serial dot println print pot value println first pot value, then we will see the map value. Then we will see the map value. Is it okay? Then I'm going to use some delay, so then only we can view the output. Okay. See. Now you see the serial monitor. Both the values are 0. Why both the values are 0? Why both the values are 0?
அப்படியே காட்டுங்க கஜேந்திரன்.
Yes, sir. Both.
ஒரே ஸ்கிரீன்ல காட்டுற மாதிரி.
Yes, sir. Now, so is it visible, sir?
Yes, Gajendran.
Yes. See, now my potentiometer is in minimum position. Therefore, my analog value, pot value, as well as map value, both are 0. Now I am going to increase the value into 25%. 25%. See, 25%. My pot value, what I am reading is 225. The equivalent map value is 56. You can visualize this one. Now, simply I will do one thing. I will take the maximum value first. It may be clear for you. See, I am taking to maximum value. What is the maximum value? Pot value will be 1023. What is the mapped value? 255. So the analog read value is from 0 to 1023, but analog write value is 0 to 255. I hope you can understand the difference. Now I bring to the middle position, 50%. The 50% is nothing but 532 and 132. Can anyone view this one? This is the output. So likewise, we are going to read the analog input value from 0 to 1023, and the entire region we are going to utilize it for analog write function. Okay, so analog values, read values, maximum is 1023. Analog write value maximum is 255. That is the corresponding value. See, whatever you have seen in the previous slide, this one only I am speaking. If it is 0, it is 0. 255, 1023. Now we will do one thing. I will make 409. Is it visible? 409 in potentiometer. We will check it in the map value. 409. Now I will make this into 409. Check the pot value. Pot value, I am going to keep it into 409. Wait. 409. What is the equivalent map value? 101. 409 means the equivalent map value is 101. Check it in the slide. Check it in our slide. It is around 102. Similarly, if I bring to 614, 614 means what will happen? 614 means as per the slide it must be 153. We will check this one. 641, 614. 614. Check the pot value. Check the pot value 614. Uh, 675. So I will reduce little. Now you check it. Now you check the value. 614. The exact map value is 153. That's all. Is it clear for everyone? So likewise, we are going to read the analog value and we are going to vary the brightness of the LED. Now there is a small change we are going to do with this circuit diagram. Now we see in the visual output. Audio output, how I can vary the buzzer sound. With the help of the same coding, we are going to change the component alone. See, now I am going to change the output component. Instead of LED, I am going to connect buzzer. This will give. See, this is my positive terminal. This is my negative terminal. Take the negative terminal, connect it over here. Take the positive terminal, connect it over here. See, now you can observe the audio output. See, now I am keeping into 0. 0. No sound. I am varying the potentiometer to the maximum precision. This is maximum output. I am bringing to 50%. So what we have did here, instead of LED, here we are going to use the buzzer. So I am going to change the decibel value by changing my analog input. Instead of buzzer, okay. Let me stop. Okay. So instead of buzzer, if I connect a DC motor, I can vary the speed of the motor. Okay. That's all. Now you see, we will come into the second part of our today's lab session. Here we are going to make our RGB LED to glow. At a time, we will make any one color in the first experiment. The second experiment, we will make the alternate colors. Okay. Here, this is your circuit diagram. This is your program part. Please observe the video once. Then we will enter into our lab session immediately. Okay. So RGB LED, as Sir told, we have 4 leads. First one is red, second is cathode, then blue and green. So this is the configuration available in Tinkercad. Okay.
You are using common cathode, Gajendra.
Yes, sir. Here I am using common cathode. So the blue terminal I am connected in series with resistor and is connected to pin number 5. Then green terminal, again I connected in series with one resistor. It is connected to the PWM pin of pin number 6. Okay. Then cathode terminal, I am directly connecting into the ground. Now as for program, here we have R is equal to 255, green is 0, blue is 0. So if R is 255, I will get red color. Now I will vary the value into green to 255, remaining 2 into 0. So I will get green as the output. Please observe there. So we arrived red and green now. For blue, what we have to do? Again, we need to change the values accordingly. It will give the blue color. So blue I am making 255, remaining 2 I am making into red. Red and green I am making into 0. That's all. The same thing we are going to do it here. So program part already you have seen. This is your setup. In the first I need to declare the pin numbers as like again the data type I am going to use byte. So byte, pin red, pin green, pin blue. All the pin numbers must be a PWM pin. Okay. Then void setup, I need to configure all the 3 pins as output. Is it okay? Then by default, we will make all the 3 into logic low. So in global declaration, I made the pin number declaration. After that, in void setup, I made all the 3 pins as a logical pin as an output pin. Then at last, by default, I made all the pin to logic low. Keep remember, we are going to use common cathode LED. In our lab session, we have a common LED, common anode in our actual hardware component. But in Tinkercad, we have only common cathode. Okay. So what is in the loop portion I need to write? I need to assign the duty cycle for each pins. Then I need to pass the duty cycle to make the PWM outputs in the corresponding pins. Okay. So in loop program, I'm going to assign the duty cycle first. R is equal to 255, green equal to 0, blue equal to 0. Then I will pass those duty cycle into the analog write function. Thereby, we will get the required output. Now we will straight away, we will come back to our simulation part. Is it visible for everyone? Shall I continue?
Yes,
Yes,
sir.
Gajendra.
So here we have Arduino board and breadboard, and it is powered with VCC and ground. So first we will pick the resistor, then we will take the new output device. Okay. So here the new output device is tricolor LED. So output device, go to output device. First is LED, the second one is RGB LED. Pick the RGB LED. So whenever you are using any new component, please read the component terminals first, then start do the wiring. See, first terminal is the red terminal. The second one is cathode. Third one is blue. Fourth one is green. There is a little variation between your actual pin configuration and this Tinkercad software. Now I am going to place the RGB LED. Then the value of the resistor. Again, by default, I am going to give 220 ohm as the resistor value. Bring the resistors. So I need a copy of this. So Control C, Control V. I'm going to connect it in all the 3 terminals, red, green and blue terminals. Is it okay? So now I have connected one terminal of my tricolor LED with resistor. The another terminal I need to connect it with the Arduino. Yes. Before that, we will check, we will note down the pin numbers from our program part. Program, what we have written: red for pin number 3, green 6, blue 5. So red pin number 3, red pin number 3, red pin number 3. Then this one what? Blue. 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 It's not mandatory. I need to use only these pins, and this is the order. Whatever the order you want, you can change it. Blue. But keep remember these pin numbers. Okay. Blue means whenever you are passing the value, the particular output will fall only in this pin. Okay.
Another important thing is they are PWM pins.
PWM pins. It must be a PWM pin. Then green from pin number 5. That's all. So RGB, all the 3 wires are connected. Now common cathode connected into ground. So common cathode I am connected into the ground. So red connected in pin number 3, then blue connected in pin number 6, green connected in pin number 5. Okay. Now we will come to the program part. Hardware is only this much. Pick the RGB LED from the output menu, then keep it in your breadboard, then start connect the wiring. Okay. Now you come to the coding part. So first we will declare the pin numbers. Again, I'm going to use the same data type. Pin red. First pin red, I'm going to declare pin number 3. Then again byte pin green. Pin green, I'm going to use pin number 6. Then byte pin blue. Blue is equal to pin number 5. So the first thing, we successfully declared the pin number. Then come to the void setup. Here I need to configure the pin numbers as an output pins. All the 3 pins I'm going to configure it as an output. So pin red, comma, output. Pin red, comma, output. Then only the changes, I need to change the numbers alone. Instead of pin red, change it into pin green. And again for blue color, pin blue. Pin blue. That's all. Then by default, I need to make all the pins into logical low. For that, I'm going to make it into logical low, digital right, pin number, comma, low. That's all. Pin number, comma, low. Please practice these things, then only this syntax will get familiar for you. Green, then blue. Green, then blue. So all the pins now I made it into logic low. So void setup, pin configuration, and then by default all the pins I'm going to make it as a low. Then what else I have to do? Come to the loop portion. Loop portion, I need to first declare the duty cycle values for the individual pin. What I'm going to do, I'm going to pass first 255 for the pin, red pin. For the remaining pins, sir, is visible? Hello? Ram sir? Hello? Okay. Then for green, I'm going to make it into 0. Blue also, I'm going to make it into 0. So these are all the duty cycle values what we are going to pass into the particular pin numbers. So what we have did, we declared the duty cycles. Then immediately we need to pass this value into the analog write function. So analog write. What is the pin number? So these are all my pin numbers. Pin red, pin green. So pin number followed by duty cycle. I'm not going to type any integer values. I'm going to type this variable name. Okay. So this is for pin red. Similarly for green and blue. So for green, so the variable name is G. For blue, variable name is blue. Is it okay? If you have any doubt, please type it in chat box. That's all. So these are all duty cycle values. These are all the commands to generate the PWM output. Now we will come to our demonstration.
Gajendran,
So, sir,
pin red is not there in digital right. Aditya,
okay. Yes, sir.
Thank you, Aditya.
Thank you.
Blue rendu thadava repeat aayirga.
Yes, sir. Is it okay now? Yes. Very good. Now we will start simulate. Please observe here, we are getting red color. Why it is red in color? Come to the code part. Or we are keeping into 255, green 0, blue 0. Again, if you compare the chart, what you have seen before that, see here, R 255, is it visible? The PPT is visible. R is 255. Sir, is it visible or clear, sir? R 255, green 0, blue 0. What color you will get? Red color. If I want to blue color, see, remaining all 0, blue is 255. If I want to get green, where green is available in the chart, please check. Green 255. It's not there. Here. See here, red 0, green 255, blue 0. Now we will do that one. Come to the simulation part. Stop simulation. Change the duty cycle value 0. Now I want to make green color. So 255. Remaining red and blue is 0. Start simulate. Check the LED output. Oh, green pin number change. Wait a minute. Green pin number 6. Oh, okay. This we need to change. Sorry. 5 and 6. Now you check. We're getting green color. Okay. Then again stop simulate. Change this.
Combination of colors மூணுத்துலயும் கொஞ்சம் டியூட்டி சைக்கிள் இருக்க மாதிரி ஏதாவது ஒரு கலர் எடுத்துக்கோங்க.
காட்டிடுறேங்க சார். So the blue முடிச்சிட்டு காட்டிட்டுமாங்க சார்?
Yes.
Now you see blue. Now you come to the chart. Shall we make this color? What are all the PWM values I need to give? 96, 0 and 255. Okay. So 96, 0, 255. Now we will check. 96. Stop simulate. 96, 0, 255. Yes, very good. See?
Sabarish 000 வேணுமா?
000 actually the black won't get appear.
ஆனா அதுதான் அவனுக்கு வேணுமா, என்ன பண்றது?
சார் அதுக்கு actually some reflector எல்லாம் ஃப்ரண்ட்ல வச்சிருப்பாங்க. See, Sabarish, here you won't see black color. You have few more layers over your window. At the time it will be appear as a black. Okay. Now it is no glow. If you want to make white color, can anyone help me what I have to type? White color. White means what I need to type? White, pure white. Pure white. Please check the chart and tell me.
255.
Very good. Now we will come back here. We will change the color 255 and 255. Pure white. It may not visible because the background also too light. Is it okay? So likewise, you can create any color you want. before that, make the connections properly and assign the pin number. See what mistake I did here. I changed the pin numbers. If you change the pin number, if you pass the PWM value, you won't get the exact output. So this is the simple task, but in practical life, using tricolor LEDs only, we are making most of the displays in our home, LED TV and all. So instantly we want to change the colors in our display. So here what we are going to do, we are going to do one small exercise. See, this is our study. Sir.
Marian sir, why black is not visible?
Marian, actually, if I'm giving all logic into 0, 0, 0, the LED won't glow. Okay, at that condition, after the LED, you will have some multiple filters in your display system. At that time, no glow means your display will appear as black exactly. Okay, here we don't have any filter, only immediately LED we are seeing. Okay, there they will keep some more layers to get the black color appearance. Okay, whenever your TV is in off condition, what color you are getting? Black color. So that is because of few layers present in your display. At the background only that LED is going to play. Okay, Marianne. Without light, your display will looks like a black. Immediately you unlock your mobile phone and check what is the color you are getting. No LED is on, therefore your display will get black indication. Okay. No glow is equal to black. Is it okay, Marianne? Hello?
Okay, sir.
Yes, okay. Now we will come back to the last exercise. It's very simple. Very simple. Here we are going to make all colors. So all colors means in a random fashion we are going to make. Sir already explained you this one. The same hardware configuration, void setup. There is no change. In loop function alone, we are going to do small change. What are this change? See here, I am going to assign the duty cycle value in a random fashion. See here, 0 to 255, 0 to 255, 0 to 255. Here you are having 3 loops. Okay. So very first time I will keep red into 0, green 0, then blue 0. Then this inner loop alone will get increment. That means R and green will be remain 0. I will keep on change the blue value. So at the time you will get few combinations. After some time, once this inner loop gets exceeded this range, immediately my second inner loop will get increment by 1. Thereby R is 0, green is 1, again all the combinations. Likewise, you are going to see multiple colors in your display. Okay, see, this is the output we are going to get it. So that animation, and here, see, this is your animation. Multicolors. Okay, can you observe the output variation? Multicolors. Now we will do the program part to achieve the same output. So hardware connection remains same. Void setup also, there is no much change. Only in the duty cycle, here I am going to introduce 3 for loops. Okay, 3 for loops we are going to use it. For loop, first outer for loop for red color, R0, then condition less than or equal to 255. Can anyone tell why it is only 255? Why it is 255? Can anyone tell why it is 255? For first for loop is for red color. Then
duty cycle maximum value.
Yes.
Antoni Surya and Shivakumar ரெண்டு பேர் ஆன்சர் பண்ணிருக்காங்க. டிக்சன் அனலாக் மட்டும் தான் எழுதிருக்காரு. அனலாக் ரைட் எழுதிருந்தா கூட சொல்லலாம். Actually, duty cycle range is 0 to 255. Maximum value 255 எழுதிருக்காங்க. ரெண்டு மூணு பேர் இருக்காங்க. கிருத்திகா எழுதிருக்காங்க.
Okay. Very good. That's all. 3 for loops. So don't forget to close 3 braces. Okay. First outer loop is for red color. Then second loop is for green. The third one is for blue. Okay. Now we will check the output. Can you see the change in colors? Now it is getting green. It will take little time because if individual steps only one only we are incrementing. If you want to make some rapid increase, that also you can do. Instead of R++ and green ++, if you make it into some steps, R is equal to +25, +30. Likewise, if you increase the step, you can see the output in a very rapid fashion. So that's all. So what are things we have seen today? The first one, analog read and make the brightness value. Okay, so LED brightness value we made it to change, then buzzer, then tricolor LED, fixed color, then multiple colors. Okay, if you want to do any extra task, means we're supposed to give 2 tasks today. Down the today's task. Day 4, task 1, interface 2 push buttons and 1 LED. If one push button is pressed, LED brightness need to increase. If another push button is pressed, LED brightness need to decrease. Okay va? So நம்ம அனலாக் பொட்டன்ஷியோமீட்டர் வேல்யூ ரீட் பண்ணி பிரைட்னஸ் வேரி பண்ணோம். இங்க கொடுத்திருக்க டாஸ்க் புஷ் பட்டன் கண்ட்ரோல். புஷ் பட்டன் நீ பிரஸ் பண்ண அப்படின்னா பிரைட்னஸ் இன்க்ரீஸ் ஆகணும். எது வரைக்கும் இன்க்ரீஸ் ஆகும்? அப் டு 255 தான். பியாண்ட் தட் the brightness won't vary. Again, if I press another push button, the brightness need to decrease. Okay, try this one. Please make a note of this. 2 push buttons, 1 LED. See the humble request. The code use text format or word format. Don't put it in PDF format. So உங்களுக்கு evaluate பண்றதுக்கு PDF format இருந்தா கஷ்டமா இருக்கு. Text format இல்ல notepad இல்லனா word formatல போடுங்க. ஓகேவா? அப்பதான் உங்க கோட் கரெக்டா இருக்கான்னு செக் பண்ணி பார்க்க முடியும் கால் பண்ணி. ஓகேவா? தென் வீடியோ எவ்வளவு மினிமல் சைஸ்ல அப்லோட் பண்ண முடியுமோ பண்ணுங்க. தென் த செகண்ட் டாஸ்க் using RGB LED create traffic signal light. So traffic signal light na ஒரே ஒரு traffic signal light pillar மாதிரி கன்சிடர் பண்ணிட்டு சிங்கிள் RGB LED யூஸ் பண்ணி அந்த traffic LED யோட அந்த அனிமேஷன் கொண்டு வரணும். So that means initially red LED, that means stop. So after some time நமக்கு என்ன ஆகுது? yellow color வருது.
டியூரேஷன் கூட கொடுத்திருக்காங்க ஜெயந்தா.
duration. So duration, okay sir, duration please make a note of it.
எல்லாருக்கும் ஈக்குவல் டைம் கொடுத்தாலும் சரி, பட் 10 செகண்ட்ஸ் அது மாதிரி தான் சொல்லிடுங்க.
Yes sir. See red color, after some time delay, that means 2 seconds we will keep. Okay, then after some time yellow 2 seconds, then green you may keep it at maybe 3 seconds, then cycle has to repeat. Okay, please do this animation and upload it. Please make a note of this. Red for stop, yellow for alert, then immediately green to go. Don't make much delays. Use the same delay. Do you have any doubt? Please type it in chat box. See, this is